All right, let's just jump right into this explainer and absolutely demystify that massive, invisible provider infrastructure you rely on out there as a field tech. When you're out in the field staring at a blinking router in some dark customer closet, it is incredibly easy to get tunnel vision. You see the immediate hardware right in front of you, but you kind of forget the colossal network that actually feeds into it. Well, today, we're going to fix that. We are going to map out the provider-side network, the exact equipment those telco companies use to beam the internet directly to your work sites. So before we even think about troubleshooting, we've got to ask a fundamental question. Where exactly does that giant telecom network end and the customer's actual service truly begin? It sounds like a simple question, right? But the answer dictates exactly how you do your job. Usually, as a field tech, you aren't configuring the hardware sitting inside the telecom company's data center. Your domain is the customer's site. But if you don't understand the origin point of the signal you're trying to fix, you're literally flying blind. We need to clearly define that boundary line today. Here's our roadmap for today's explainer. We're going to hit the internet origin, check out the aggregation switch, move on to the provider router, demystify the ONT device, and finally, wrap up with some rock-solid field troubleshooting steps. Kicking things off with Section 1, where does the internet actually come from? Because even though you aren't configuring this provider-side gear, understanding it, that is your absolute secret weapon in the field. Pinpointing this boundary is huge. It helps you figure out instantly if a problem is sitting right there in the customer's building or if it's miles away in the telecom core. Picture this: a massive, highly fortified telecom building. From that building, an intricate web of underground cables stretches out across the city, eventually reaching the exact wall of the home or office you're standing in. That entire journey is the provider side. If you can confidently pinpoint where their responsibility stops and yours begins, you will never waste time trying to fix a localized issue when the real problem is a downline halfway across the city. Okay, moving right along to our first massive piece of hardware in Section 2, the aggregation switch. So what is this thing? Well, this device sits at a central point in the provider's network. It takes thousands of individual copper or fiber optic cables and literally groups all that traffic together. Think of it as a heavy-duty traffic manager. You've got all these individual homes and businesses all sending out data requests at the exact same time. The aggregation switch grabs all of those separate, smaller streams of data, bundles them up super efficiently, and fires them straight into the massive, high-speed backbone of the telecom network. I love this analogy because it perfectly illustrates why this device matters. Think about a massive water funnel. You've got thousands of tiny individual pipes, those are your customers, all pouring water into the wide top of that funnel. All of that water compresses and shoots out of one ultra-fast giant pipe at the bottom. But here's the absolute critical takeaway for you in the field. If you arrive at a site and notice that several blocks are experiencing the exact same outage, you can confidently suspect a bottleneck or a failure way upstream, right at the aggregation switch level. Now, heading further down the line, we arrive at Section 3, the provider router. This piece of gear is the high-level director. It knows exactly how to take a specific customer's request, send it out to the global internet, and securely drag that response right back. While the aggregation switch is just bundling traffic together, this provider router is making the really complex decisions about where that traffic actually needs to go. It handles the high-level routing using advanced heavy-duty protocols, things like BGP and OSPF, to ensure that the data leaving your customer's location reliably finds its target anywhere in the world, and, most importantly, finds its way back. To put that into a real-world perspective, if a customer's little office router is just the front door of their building, the provider router is the massive, sprawling highway junction that ensures millions of cars don't just crash into each other. It's an enormous, smooth-flowing intersection that constantly reads the map of the entire internet, actively rerouting data around traffic jams or broken pathways. It ensures that the physical connection your customer pays for actually means something on a global scale. All right, zooming all the way down to the customer's actual premises, let's look at Section 4, the ONT device, or what I like to call the interpreter. The ONT, the optical network terminal, is, at its core, simply a translator. It takes the invisible laser light sent by the telecom company and physically translates it into electrical Ethernet signals that a normal router can actually understand. When the telecom company runs fiber to a home, they are literally sending data via pulses of light. But your standard consumer or business router, it can't read light. It reads electricity. So the ONT is that critical bridge standing between the massive optical network of the provider and the local electrical network of the customer. Now, here is an absolutely crucial distinction when we talk about the golden rules of IP. We've got a very clear division of labor here. The ONT only passes data. It's strictly a physical bridge. It doesn't care about IP addresses, it's not handing out local network configurations, and it doesn't manage DHCP. It just translates. That's it. The customer CPU router, that's the brain of the local network. It takes that translated data and manages the actual logic of the connection. Knowing this difference is vital so you don't end up blaming the wrong piece of hardware for a routing error. Which brings us to what might be the single most important rule in this entire explainer, the universal red light rule. As a field tech, if you walk into a server room or a living room and you see a red or flashing PON or optical light on that ONT, you stop immediately. Because spending all day fixing the customer's router is not going to help if the physical pipe is cut. A red light means the ONT cannot see the provider's network. The laser light is literally not reaching the building. No amount of restarting the customer's router or tweaking IP settings is magically going to fix a cut fiber line down the street. So, how do we put all this together? Let's turn this knowledge into a totally actionable protocol in Section 5, Field Troubleshooting Steps. Whenever you arrive at a site, I want you to instantly visualize this connection chain. If you do, you'll never be left guessing where a breakdown happened. Your troubleshooting has to be logical, right? It has to be sequential. First, the physical pipe. Is the fiber actually connected and transmitting light from the provider? Second, the Ethernet handoff. Is the physical Ethernet cable between the ONT and the router securely plugged in and working? And third, the logical IP connection. Is the customer's router properly configured to handle the traffic? If you just skip around this chain willy-nilly, you are going to waste hours of your day. So, you execute this simple, two-step protocol every single time. Step 1, look at the ONT, period. If you see that red alarm light, stop right there. The problem is on the provider's side. You call the control room, you report a link failure, and you're done. Step 2, if, and literally only if, the ONT lights are green and perfect, but there's still no internet, then you shift your focus to the customer's equipment. Now you check the Ethernet cable and you check the router configs. Follow this sequence and your efficiency out in the field is going to skyrocket. I really want to leave you with this crucial quote from our sources today because it perfectly sums up why the ONT is your best friend out there. The ONT is the translator. If the translator cannot hear the telecom company, it cannot pass any data. It really is the ultimate gateway. Everything upstream, that aggregation switch, the provider router, the miles and miles of fiber optic cables, all of it completely relies on this single device successfully hearing the signal and passing it along to the customer. So now that you've totally mastered these physical network devices and you know exactly where the provider's responsibility ends and your troubleshooting begins, the big question is, what happens next? Are you ready to conquer exactly how that data logically routes itself across the globe in our next explainer? We've built the physical roads today, but next time we're going to dive deep into the rules of the traffic. Until then, keep these steps in mind out in the field and happy troubleshooting.